5. We need to find P of A intersection B, right? So first also should be black and second also has to be black. So 26 by 52 into 25 by 51. So 1 time, 2 time, which is 25 by 102, right? Now we'll move to the third question. A box of oranges are there. Okay, we are going to select 3 oranges from it. Okay, when you are selecting 3 oranges from the box, you will approve the box if all the 3 are good. Suppose if even 1 orange is not good, the box will not be approved, it will be rejected. Okay. Now out of the 15 oranges in the box, 12 are good, 3 are bad. Now you are going to pick 1 by 1 orange from the box which will not be replaced, right? So how many good oranges are there? Which is 12. How many bad are there? Which is 13. Now you are going to pick 1 by 1 orange from the box. You are going to pick 3 oranges from it. If all the 3 are good, the box will be approved for the sale, right? First I am going to take first orange. Okay, totally 12 good ones are there out of 15. Next I am going to take second orange. How many good oranges will be there? Since already 12 were there, you picked it up and you have kept the orange out of the box, right? Now remaining 11 oranges will be there, which is good orange. I am keeping this orange also out of the box. Then 10 out of 13. Totally 13 oranges will be there. In that 10 are good, right? Now I am going to find the condition that the box will be approved for the sale. So which is A, B and C, right? So 12 by 15, 11 by 14, 10 by 13, right? So divide by 5 table, 2 times, 3 times, 3 12s are 4, right? 2 7 times. So multiply the numbers in the numerator. 4 into 11, 44, 7 into 13, 91. So this is the probability that the box will be approved for the sale. Now we can move to the next question. So you are going to toss a coin and going to roll a unbiased die. Okay. Now you will be getting some sample space. From that sample space I am going to take 2 events. Even A is head appears on the coin. Even B is 3 appears on the die. The question is been whether A and B are independent even or not. We have to find whether they are independent or not. So before solving this problem, we will write down the sample space of it, right? So when your sample space is, you are throwing coin and die. Okay. So head comma 1, head comma 2, head comma 3, head comma 4, head comma 5, head comma 6. Then tail comma 1, 2. Similarly what you have done for the head, same will be followed over here when tail appears, right? So you have a sample space of 12 outputs, right? What is event A? Event A is head should appear in the coin. So how many outputs are there? 6 outputs are there. 6 by 12. What is B? B is 3 appears on the coin. So where 3 comes, just put circle near that. Okay. Only 2 events. 2 by 12. Now what is P of A intersection B? You check where I have ticked and circled for the same data. Only for this I have ticked and circled, which is 1 by 12, right? This is the values for P of A, P of B and P of A intersection B, which I have found from the sample space. Now I am going to check whether they are independent or not. Okay. So the condition is for P of A intersection B, in independent cases P of A into P of B, right? So what is P of A? 6 by 12 into 2 by 12, cancel, which comes one time, so 1 by 12. This is equal to this. Therefore A intersection B values same in both the cases. Therefore yes, A and B are independent of each other. So therefore it is an independent event. That's all, right? So we'll move to the next question from this exercise. There is a die. In that die, the number 1, 2, 3 are written in red color, whereas 4, 5, 6 are marked in green color. Now two events has been given to us. Even A is getting an even number when the die is rolled. What is B? B is getting a green color when the die is rolled. Now we have to check whether A and B are independent of each other or not, right? Now this is your sample space, right? So what is P of A? It should be an even number, right? What is even number? 12, 2, 4, 6, which is 3 by 6. What is P of B? Which has to be in the form color green, right? So when it is green, just circle it, 4, 5, 6, which is 3 by 6. We need to find P of A intersection B. Okay, so same, check where I have ticked and circled for the same data. For 4 and 6 I have ticked and circled. So only two events are there, which is 2 by 6. If you simplify, you will get 1 by 3. Now I am going to check whether they are independent or not. To check that condition, we need to find P of A intersection B, which is P of A into P of B. 3 by 6 into 3 by 6, which is 1 by 2 into 1 by 2, which is 1 by 4. See, the value of A intersection B in both the cases are not equal. Therefore, it is not an independent event. Not an independent event. Right? I hope you are clear with this answer. Now we will move to the next question. Let E and F be the events. Okay. So probability of E is 3 by 5. F has been given. E intersection F has been given. The question is, we have to check whether E and F are independent or not. Okay. This is very simple sum. Right. So to check the condition, you have to find P of E intersection F. What is P of E intersection F? P of E into P of F, which is 3 by 5 into 3 by 10, which is 9 by 50, right? See, P of E intersection F, what we have derived over here is 9 by 50, but that given data it is 1 by 5. Whether they both are equal? No. Therefore, E and F are not independent even, right? Now we will move to the next question. P of A is 1 by 2, P of A union B is 3 by 5, P of B is P, which is unknown value. Now you need to find the value of P under two conditions. The first condition what has been given is mutually exclusive event, and second condition is independent event, right? So we will find the value of P under both the cases, right? So mutually exclusive event, right? So what do you mean by mutually exclusive event? That is, in case A and case B, there is nothing common in between them. Okay, we call it as mutually exclusive event, right? It is nothing but P of A intersection B is 0. There is nothing common between A and B, right? Now P of A and B has been given. Our formula is, which you have learnt in your previous classes, P of A union B is P of A plus P of B minus P of A intersection B, right? So P of A union B is 3 by 5, P of A is 1 by 2, P of B is P, and what is intersection, which is 0. So no need to solve it. So 3 by 5 minus 1 by 2 equals to P. Now you need to find the value of P, right? Take LCM between 5 and 2, which is 10. When you cross multiply, it is 6 minus 5. Therefore, P equal to 1 by 10, right? Now we will go to the second case. What is second case? Independent even, right? So we are very familiar with independent even. Okay, we are going to use same formula. P of A union B equal to P of A plus P of B minus A intersection B. A intersection B can be written as P of A into P of B. Why? Since it is independent even, A intersection B can be taken as P of A into P of B. What is A union B? 3 by 5 equals to 1 by 2 plus B minus 1 by 2 into P. Bring this 1 by 2 here. So 3 by 5 minus 1 by 2 equal to P minus P by 2. See, already we have taken LCM of 3 by 2 minus 3 by 5 minus 1 by 2, which is 1 by 10. 1 by 10 equal to what plus P minus P by 2, which is P by 2. Just cross multiply, you will get P is equal to 2 by 10, which is 1 by 5. So this is the value of P in two different cases. The first case is mutually exclusive even, whereas the second case is independent even, right? Now we can move to the next question. P of A is 0.3, P of B is 0.4. They have mentioned that A and B are independent events, right? So with the help of those two data, okay, since they have mentioned as independent event, we are going to find all the four required answers from the four subdivisions, right? So what is P of A intersection B? You know that since it is independent event, P of A into P of B, which is 0.3 into 0.4, which is 0.12, right? Next, second subdivision in it. We need to find the value of P of A union B. What is P of A union B? P of A plus P of B minus P of A intersection B, right? So P of A is 0.3, P of B is 0.4. What is P of A intersection B, which we have already found it as 0.12. So 0.58. Okay. Now third subdivision, we need to find the value of P of A bar B. I hope you remember the method. Okay. What is P of A bar B, which comes under the which condition? Conditional probability method, right? So P of A bar B is P of A intersection B by P of B. What is P of A intersection B, which we found it as 0.12. What is P of B? 0.4. Okay. For better understanding, as I said you, I will try to avoid solving in decimals. So multiply 100 in numerator and denominator, which becomes 12 by 40. Divide by 4, which is 3 by 10. So 0.3 is the answer. Next, fourth subdivision, P of B bar A, nothing, P of A intersection B divided by P of A. So 0.12. What is P of A? Which is 0.3. Multiply 10 on numerator and denominator, 100 on numerator and denominator, which is 12 by 30, 4 by 10, which is 0.4, right? So this is the solution for all the four subdivisions from the question. Now we will move to the next question. P of A is 1 by 4, P of B has been given, A intersection B also has been given. We need to find the value of P of A dash intersection P of A, P of A dash intersection B dash. So A dash intersection B dash is A union B the whole dash, right? So this is what you need to find, right? You might have a doubt, sir, how do you derive this formula? I hope you remember Venn diagram. I will explain you with a shortcut in this Venn diagram, right? So in this Venn diagram there are two events A and B. 1, 2, 3 and 4. So what are the data which comes in A? 2, 3. What it comes in B? 3, 4. Now I need to find A dash intersection B dash. What is A dash which is not in A? 1, 4. What is B dash which is not in B? 1, 2. We need to find the value of A dash intersection B dash, which is 1. What is this 1? The 1 is which comes out of A and B, that is this part is P of A union B, right? When you need an answer which is not in this, what does it mean? P of A union B whole dash. How to find P of A union B whole dash? Which is 1 minus P of A union B. This is what you need to find. I hope you remember this method, or you have learnt in your previous classes, or else if you find difficulty in this, just follow the steps, right? First we will find the value of P of A union B. So P of A union B equal to P of A plus P of B minus P of A intersection B, right? So what is A? 1 by 4, 1 by 2, 1 by 8. If you take LCM as 8, which is 2, 4, 1. So which is 5 by 8. Now you need to find the value of P of A dash intersection B dash. What is it? 1 minus A union B, which is 5 by 8. So 1 minus 5 by 8 is 3 by 8. So this is the answer for P of not A and not B. Now we can move to the next question. P of A is 1 by 2, P of B which is 7 by 12, whereas P of A dash union B dash is 1 by 4. Now we have to check whether A and B are independent events or not, right? So P of A dash union B dash equals to P of A intersection B whole dash. They have mentioned that P of A intersection B whole dash is 1 by 4. Then what is P of A intersection B, which is 1 minus 1 by 4, 3 by 4, right? This is the value of A intersection B which I have derived from the given data. Now we have to check whether it is independent event or not. To check, you have to use the independent event formula. What is P of A intersection B? Which is P of A into P of B. P of A is 1 by 2, P of B is 7 by 12, which is 7 by 24. See, both the data are not matching. Therefore, A and B are not independent event. That's all. Right? So we can move to the next question. They have mentioned that A and B are independent events. From that, they have given A equal to 0.3, B is 0.6. Now we need to find the answer for all the 4 subdivisions given in the question. Right? It's very simple question, pa. Okay. What is P of A intersection B? Which is P of A into P of B. Right? So 0.3 into 0.6, which is 0.18. Now second subdivision. Find P of A and not B. Okay, that is P of A intersection B dash. What is P of A intersection B dash? Which is P of A minus P of A intersection B. Remember this formula, P of A intersection B dash. So P of A minus A intersection B, right? What is P of A? 0.3. What is P of A intersection B? Which is 0.18, right? So 0.12. Next, third question. P of A or B, nothing but P of A union B. What is P of A union B? P of A plus P of B minus P of A intersection B. Okay, what is P of A union B? P of A plus P of B minus P of A intersection B. What is P of A? 0.3, 0.6. What is intersection over here, which we have already derived as 0.18, right? So if you solve, you will get 0.72, right? Next, last subdivision, P of A union B whole dash, which is 1 minus P of A union B. 1 minus, what is A union B value, which is 0.72. So 1 minus 0.72 is 0.28. Okay, so this is P of not A or not B. Okay, that is neither A nor B. It should not come in A also and B also, which is A union B, the whole dash. Now we can move to the next question. Die is rolled thrice. Find the probability of getting an odd number which has to appear at least once. Okay, so what does it see? When you are throwing a die, you may get an odd number or even number, but the condition is out of the 3 throws, at least one time you should get odd number. So what do you mean by at least one time? It could be one time, or it can come twice, or it can come thrice. So we have to find probability of getting an odd number at least once, right? So what does it mean? We have to get probability of odd number one time, probability of getting odd number 2 times, and probability of getting odd number 3 times. Instead of finding this value, better you can find this value as 1 minus P of getting even number thrice. That is, you won't get any odd number, all the 3 numbers will be even. So if you find this value, from total probability subtract this value, right? So 1 minus P of first should be even, second also should be even, and third also has to be even number, right? Now 1 minus, what is probability of getting even number in first case? Even number into even number into even number, right? So 1 minus 1 by 2, 1 by 2 into 1 by 2, which is 1 minus 1 by 8. If you take LCM, which is 7 by 8. So the output of getting at least one odd number is 7 by 8. Okay. Now we can move to the next question. A box contains 10 black balls and 8 red balls in it. Now you are going to pick 2 balls from the box with replacement. What does it with replacement means? Suppose you are taking a ball, it might be black or red, you will replace the ball into the box again, right? Now with this data, you need to find 3 subdivisions from there. The first subdivision is, while taking both the balls, both has to be red. That is, the first ball should be black ball, and second ball also should be black. That is, you are going to take 2 balls from the box, both has to be black. First is also black, whereas second is also black. So probability of taking black ball is 10 by 18. How does this 18 comes? Because totally there are 18 balls in the box, 10 black and 8 red. Okay. Second is also black, which is 10 by 18. If you simplify, which is 5 by 9 into 5 by 9, which is 25 by 81. Okay. Next, second subdivision. They said you that the first ball has to be black and second has to be red. Okay. So the first ball is black and second has to be red. Okay. What is first ball black? The probability of getting black ball is 10 by 18. Then probability of getting red ball is 8 by 18. If you solve, you will get 5 by 9 into 4 by 9, which is 20 by 81. Now third subdivision, they said you that one of the ball is black and another has to be red. That is, first might be black, second might be red, or else first can be red, second might be black. So you have to find output for these two cases and add both. That is, first is black, second is red, plus first is red and second is black, right? So what is the probability of getting black ball? 10 by 18 into 8 by 18 plus first is red, 8 by 18 into 10 by 18, right, which is 5 by 9 into 4 by 9 plus 4 by 9 into 5 by 9, which is 20 by 81 plus 20 by 81. Therefore, 40 by 81 is the answer for this question. I hope you are clear with this, because there is nothing difficulty in it, or just normal calculations with remembrance of small formulas. Now we can move to the next question. Probability of solving a specific problem by two persons A and B has been given as P of A is 1 by 2 and P of B is 1 by 3, where they both are independent of each other. That is, the probability for A and B to occur is independent to each other, right? Now we need to find the two values from this given data. That is, a problem can be solved by A is 1 by 2 and B is 1 by 3. The first question is, the problem has to be solved, whether it is solved by A or whether it is solved by B alone, or whether they both are working together and solving or not. I am least bothered about it. I need the answer for this question. So when a problem is solved by A and B or by any of the information, we need to find A union B. What is A union B? It could be solved by A, or it could be solved by B, or it is A intersection B. Okay, right? Since they said it is independent even, which can be taken as P of A plus P of B. What is P of A intersection B? Which is P of A into B, right? 1 by 2, 1 by 3 minus 1 by 2 into 1 by 3. So 1 by 2 plus 1 by 3 minus 1 by 6. You can take LCM as 6. 3, 2 minus 1, which is 4 by 6. So that it gives you an output as 2 by 3. Second question. What is second question? Exactly anyone has to solve. Exactly one of them. It should be solved by A alone, or it has to be solved by B alone. So the formula for that is P of A union B minus P of A intersection B, which will give you the solution when the problem is solved by exactly one of them. What is P of A union B? Which we found it as 2 by 3. What is P of A intersection B? For P of A intersection B, we found it as 1 by 6. You can take LCM as 6, which is 4 minus 1. So 3 by 6, which is 1 by 2. So this is the answer for the both the subdivisions from this question. Now we can move to the next question. In this question, you have 3 subdivisions in it. Okay. So the data or the sample space is common for all the 3 cases. Okay. A card is drawn from the well shuffled pack of 52 cards. Okay. Each and every question has 3 data, that is E and F. We have to check whether they both are independent or not. Okay. Now first subdivision. Okay. P of E. What is E over here? Okay, when you are picking a card, we have to check whether the card is an spade. Okay, so spade over there is 3 by 52. What is F? Okay, F is the card picked out is an ace. Okay, so there are 4 aces in the total of 52 cards. Now you need to find P of E intersection F, that is ace from spade. So which is 1 by 52. Now we need to check whether it is independent event or not. To check it is independent event or not, we need to find P of E intersection F, which is P of E into P of F. 13 by 52 into 4 by 52. Sorry, I mentioned it as 52, right? 4 into 13 is 52, one time. Your answer is 1 by 52. See, P of E intersection F is 1 by 52 in both the cases. Therefore, E and F are independent events, right? Now we can move to the second subdivision in the question, right? Now the condition for E is it has to be a black card. How many black cards you have out of 52? Which is 26 by 52. The condition for F is it has to be king. How many kings are there? You have 4 kings out of 52. Now what is E intersection F? It should be black and it has to be king. So you have 2 kings which are in black in color. So 2 by 52. Now I am going to check whether they are independent or not. So P of E intersection F is 26 by 52 into 4 by 52, okay, which is 2 time 1 time divide by 2, which is 2, okay. So 2 by 52, which is equal to E intersection F. So therefore E and F are independent even, right? Next we can move to the third subdivision in the same question. P of E, okay. The P of E for this condition is king or queen. Totally you have 4 king and 4 queens in this pack. Totally 8 cards are there. Next, what is F? It can be queen or jack. Okay, you have 4 queens and 4 jacks in it, which is 8 by 52. What is intersection E and F? In both the cases, queen comes common in P of E and F. So totally you have 4 queens in this box, which is 4 by 52, right? Now you have to check whether they are independent or not. So 8 by 52 into 8 by 52. So if you solve by fourth table, which is 2 by 13 into 2 by 13 in it, okay, which is 4 by 169. See, the value of E intersection in both the cases are different, right? So therefore E and F are not independent even, okay, right? I hope you are clear with this. Now we can move to the next question. In a hostel, the students read certain type of newspapers. When they made a survey, out of the students in the hostel, 60% of the students reads Hindi newspaper, 40% of students read English newspaper, whereas 20% of the students read both the newspapers. Now we will solve the first subdivision, right? First subdivision is the student who doesn't read any of the newspaper, neither of the newspapers, that is P of H union E whole dash. The one who reads none of the newspaper from this. So this can be calculated 1 minus P of H union E, right? 1 minus, what is P of H union E? P of H plus P of E minus P of H intersection E, right? Since all the data are given, it is quite easy to find this answer. 60 by 100 plus 40 by 100 minus 20 by 100. 1 minus 100 minus 20 is 80 by 100, which is 20 by 100. So 1 by 5. So 1 by 5 are the number of students, those who don't read, or the probability of the students, those who don't read any of the newspaper. Now we can move to the second subdivision in it. This is conditional probability, right? If she reads Hindi newspaper, what is the probability that the student will read English newspaper also, right? So the condition is definitely she is reading Hindi newspaper. So P of E bar H, right? So what is P of E bar H? P of E intersection H divided by P of H, because definitely she is reading Hindi newspaper, right? So what is P of E intersection H? 20 by 100 divided by Hindi is 60 by 100. If you cancel this, you will get 20 divided by 60, which is 1 by 3. In this third subdivision is, if she reads English newspaper, what is the probability that she reads Hindi newspaper also? That is, the condition over here is definitely she is reading English newspaper. So P of E intersection H by P of E. Okay, intersection is 20 by 100 whole divided by, what is E? 40 by 100. You will get 20 by 40, which is 1 by 2. This is the probability of the required questions from the given data, right? I hope you all are clear with the independent events of the problems from your textbook, right? If you have any other doubt, you can post your doubt in the comment section. I will clarify the doubts in it, right? So in next video, I will be posting the video on the Bayes theorem. So if you have any clarification in it, you can refer to that video, right? Okay, now you can solve questions from other sources to have a better knowledge about the independent events. If you have any doubt in the other sources also, just post the question in the comment section. I will clarify your doubts. Okay, right. I hope you understood this session. Okay, all the best. Do well in your boards exam. Please subscribe the channel, and you can forward the videos, and you can ask your friends to subscribe and ask them to learn from these concepts, videos from our channel. Okay, all the best. Do well. Thank you.